All right, question number 8. So we're going to launch this projectile at 40 degrees with a speed of 60 meters per second. And we're going to determine the maximum height reached by this projectile. Now, I did a version of this problem before, so this one I'm going to work through a little bit quicker just so you get a feel for the numbers again and you can check your answer. So this is 60 meters per second. The angle is 40 degrees. Ux is the horizontal component, and uy is the vertical. Again, these are vector components, so just working with this here. Again, no major drama, just kind of making sure that we get this figured out. So we'll take 40 times the cosine, multiply it by 60. So we're getting 46.0 when we round. That's the x component. And then the y component is going to be 60 times the sine of 40. Again, no big deal. We get 38.6 meters per second. So just kind of continuing, let's go ahead and just label out what's going on. And I want to just illustrate again with a picture. So we're launching this thing. It goes into the air, and then it lands. So S is unknown. That's the vertical height that it reaches. That's this right here. This total horizontal distance, so this is x. This is x naught right there. So that's really the answer to F. This is the answer to part D. Now, let's be clear on one thing. I'm going to go ahead and get the height it reaches first. So using my numbers, that's 38.6. One thing I want to note, when we reach our maximum height, S, note that Vy is 0 at the top. We've discussed this before, so at this point you're just going to need to use that fact. The other thing that we need to be clear on is that we're only covering this leg of the trip. So the time that we get here is only going to be half the time. Okay, so Vy is going to be 0, A is going to be 10 because it's gravity. Now T is going to be an unknown at this point, but we're going to go ahead and solve for it in a second. So the maximum height reached, we're going to use for part D, V squared is U squared, and let's give them little y subscript so we remember that we're in the vertical direction, minus 2as, again using this equation here. So that 0 squared is 38.6 squared minus 20 times s. So we'll square this, and then we'll divide by 20. And that's going to give us a height of about 78.4. Again, you might have, or 74.4, and again, you might have got a slightly different answer, but just to be clear, like if you're off by 1 or 2 decimal points here, let's kind of be reasonable about our answers and realize, hey, like it's probably just a rounding error, so we don't need to worry about that. So that's 78.4 meters on that part. Now, for the time it takes, so the time up is going to be given by Vy equals negative AT plus Uy. Again, use the formulas that I've given you here. So 0 is negative 10 times the time plus 38.6. And when we solve, we're going to get that the time up is 3.86 seconds. So just to be clear, this will be 3.86 seconds. But to get the total time, the time up and the time down, we're going to go ahead and double. So the total, and you know what? I don't want to put a box around that, so I'm going to get rid of that box. Because we're going to go ahead and get the total time in a second. So let's not put a box around that part. Try to be careful about this. There we go. So that's just the time up. But the total time is going to be double the time. So it's 2 times the up time which is going to be 2 times 3.86. And that's going to give us a total time of 7.72 seconds. Perfect. So that's part F. So to get the horizontal range it covers, we're going to finally, let's put in, so we have initial horizontal position of 0, the final's unknown. UX is what we got up here as 46.0. So when we put all those numbers together, we're going to get that the horizontal position at the end of this problem is going to be 46.0 times 7.72 plus 0. So 7.72 times 46.0, and that's going to give us 355.1 meters. So that is our final position. So again, I did this one a little bit quicker than I did the previous practice exams. So that's mainly because I want to show you the process, but the assumption I'm making is that you've sort of figured out much of the details. Those you should definitely email or see me about before Wednesday.